Now look at the second task. Second task says that prove that AH and AG are equal. AH and AG are equal. Now normally when we want to prove AH and AG are equal, we will try isosceles triangle. In this case, I have to connect GH and prove the angles are equal, but clearly in this question, I don't want to go this route. Simply because these angles are too difficult to find. Okay, then how can I prove anything that is how can I prove they're equal then? We should also realize that in this question, since AG is a diameter, sorry, AG is not diameter, AG is the radius. Okay, so maybe there are other sides we can use. Maybe I prove AH equal GF, AH equal BG, AH equal GC. Now those are all diameters, you see? That's the first thing. Second thing is AH. Since we already proved parallelogram, now AH is equal to the opposite side CF. Maybe I can use CF, right? So instead of looking at the isosceles triangle AHG, we should maybe look at other sides. There are a few to choose from. Okay. Now one other thing is that there is one condition 60 degree at A. Now we didn't use this condition in part A. Now I think we will use this condition in part B. Now there are many solutions for part B. Let's first look at the standard solution first. The standard solution, you need to connect GC. So you can see I add a line at GC. Part B. Join GC. Okay. Now since G is the center, we will know this angle will be twice angle A. Now angle BGC is twice angle BAC equals 60 degree times 2 equal 120 degree. And that is angle at the center twice angle at the circumference. Okay. Another thing is, since this is 120 degree, these angles must be 60 degree, right? This angle 60 degree. Therefore, angle CGF equal 180 minus angle BGC equal 60 degree. Adjacent angles on a straight line. Okay, now of course and then I will find out, oh, since this is 60, this is also isosceles triangle, do you see? Now GF equal GC. Now in triangle CGF, since GF equal GC, they are radii. We know that the other two angles must be 60 degree as well. Now GFC and angle GCF are also 60 degrees. Base angles, isosceles triangle. Right? So this is 60 degrees, 60 degrees, 60 degrees. And then we can say, oh, this is actually, what do I say? An equilateral triangle. And then you can say, can I say directly? Maybe to be safe, I will say the three sides are equal first. Now GC equal GF equal FC. Sides opposite equal angles. Okay, now is this useful? I think so. I think so. Because they are all equal now, the three sides are equal now, then I can say, oh, the FC and the radius are equal. And since FC and AH are equal. Now because AFCH is a parallelogram, we know AH equal FC, opposite sides of parallelogram. Now AH and FC are equal, and AG and GF are equal radii. So we have AH and AG equal. This is the standard solution. Standard solution, you use geometry only, and you don't use any like calculation. You just you have equal sides, equal angles, and so on, and you see the figures. That's the standard solution. And also you make use of the 60 degree. You know what I mean? But in this case, you have to connect GC to create this not isosceles equilateral triangle. This is what I call solution 1. Okay. Now look at solution 2. Solution 2. This solution I think I admire. In this solution, we do not have to connect GC. Therefore, I will not find these angles. I will not find 120 degree. I will not find this 60 degree. What I will do is I will find this angle and BAC are equal. So angle BAC and angle BFC are equal 60 degree. Angles in the same segment, 60 degrees. Right? And then I can use in triangle BFC. So instead of the equilateral triangle, I'm looking at a special triangle BFC. Now BFC is a 60-90 degree triangle. We have angle BCF equal 90 degree, proved in A. So we can use it's not the most typical in geometry. We can use trigonometry. That is cosine 60 degree equal CF divided by BF. And we know that CF divided by BF cosine 60 is 1/2. And then we have CF equal 1/2 times BF. Now BF is a diameter, so 1/2 BF is equal to the radius, which is GF. Okay, so instead of it's a little bit simpler, I think. So now we know CF and GF are equal. Now we also know CF basically here. Basically here. Now I'm going to write the highlighted arguments again. That is because AFCH is a parallelogram. It's proven, and therefore AH and CF are equal, opposite sides of parallelogram, and therefore also GF is diameter, so GF equal AG, therefore AH equal AG. Okay, so the second solution, I saw that from the students, so I think it's a good idea. So that is the second solution. Are there more solutions? I think so. But because at first I thought about myself, I didn't think about connecting CG. I also didn't think about the cosine value. I thought about drawing a line perpendicular to G, from G perpendicular to BC. This is my suggestion. It's not related, but I thought about this line. The reason is that I think this line will be half of FC, because inside the triangle I am drawing a line that is basically connecting the midpoint to midpoint. So I think this line will equal to half of FC. And I'm trying to prove that this line is also half of the diameter. Now, half of FC means half of AH, right? Half of FC means half of AH. Now, if I can also prove this line is half of diameter, right? That means AH and AG are equal. So why is it half of the diameter? So sorry, when I say diameter, I mean radius. Radius. Now this line is also half of the radius because you see this triangle is a. I guess again I have to use the cosine value then. Then this solution is not simpler than the second solution because I want to say, oh, this line is half of BG, and to say that I have to use the cosine value. So that is what I think. So what I mean is that the line connecting GC is not completely necessary, but to realize that AG is one of the radius is crucial, in my opinion. What do you say? Let me know. Let me know. I want you to do the correction. That means redo to make your answer correct. To make your to score perfectly in your homework, so that you can improve. That's the only way you can improve, because technically for the knowledge points, all of you should know all the theorems already. It's just how to use them, and you still need to practice. So redo this part. Okay, that's all.